Now let us see how to determine the elimination half-life. For that, first we'll write down our final equation of elimination rate constant, and that equation was Ke is equal to 2.303 upon T log of C0 upon C, where C0 is the initial concentration at time T0 and C is the concentration of drug in plasma at time T, which is yet to be eliminated. So, as we want to determine the half-life, first thing that we are going to do is that we are going to take this T towards left-hand side, and we are going to take this Ke towards right-hand side. So, if you take this T, which is already present towards denominator on right-hand side, to the left-hand side, it will go to the numerator, and Ke is going to take its place. So, if we rearrange the things, T is equal to 2.303 upon Ke log of C0 upon C. This is the equation that you are going to get. Now, what is elimination half-life? Elimination half-life is the time required to eliminate 50% of drug from the plasma. So, when T is equal to T half, at that time, your concentration is going to become half the initial concentration. That is, it will be equal to C0 by 2. Right? So if elimination half-life is the time required to eliminate half or 50% of drug from the plasma, then at T half, your concentration of drug in plasma will be 50% of the initial concentration. So it will be half the initial concentration. So at T is equal to T half, your concentration C will be equal to C0 by 2. So what you have to do, you have to put these values in this previous equation. So if you put these values in previous equation, then this equation will become T half is equal to 2.303 upon Ke into log of C0 divided by C0 by 2. Now, if you solve this thing, you will get T half is equal to 2.303 upon Ke into log of, so on rearranging the things, C0 and C0 will get cancelled and 2 will come to the numerator, so it will be log of 2. Further solving this thing, the logarithm of 2, it is going to be 0.3010. So 2.303 upon Ke into 0.3010. Now, if you multiply 2.303 with 0.3010, your answer is going to be T half will be equal to 0.693 divided by Ke. So this is how you can determine the elimination half-life from the elimination rate constant formula. Now let us see how to determine the clearance for IV bolus administration, which is a one-compartment open model. You all know that clearance, which we also call as total clearance over here, can be represented as CLT, where T is to the subscript, capital T is to the subscript. So clearance CLT, its formula will be rate of elimination divided by plasma concentration. This is what we have seen in our previous topic related to elimination in our previous unit. So clearance is equal to rate of elimination upon plasma concentration of drug. If we put the values over here, then rate of elimination is nothing but it is dx upon dt. This is the term which we have used previously. Rate of elimination is nothing but it is dx upon dt. And plasma concentration is C. It is the plasma concentration at any time t, which is yet to be eliminated. So dx upon dt upon C, this is what we are going to get. Now, from equation 1, we know that dx upon dt is equal to minus kex. So instead of dx upon dt in the numerator of clearance formula, we are going to write kex over here. Okay, so your formula for clearance will become, therefore clearance will be equal to kex upon c. Now remember that in your equation 1 there was a negative sign over here, but we cannot put that negative sign in this case. This is because that negative sign is related to decrease in concentration. So we can skip that negative sign over here, and hence we have not incorporated the negative sign in this formula. So now your formula for clearance is CLT is equal to KEX upon C. So the same equation, we have rewritten it in this format, Ke into x upon c. And you all know what is x upon c. X upon c is nothing but it is volume of distribution. So now your clearance can also be written as CLT, that is total clearance, will be equal to Ke into volume of distribution, where volume of distribution is equal to x upon c. So in this way, this will be your formula for total clearance.